All right, next up, we're going to go here to NovaCentrix and try to talk to someone who can give us a little more information about what's going on right here. Let's go to the front here and see who's around. Hello.
Hi, how are you?
Fantastic. Alex, nice to meet you. I'm Alex as well.
Hi, nice to meet you.
Can you tell us about your company and your products that you brought here?
You bet. So NovaCentrix has been around for about 20 years now, and we're the world's leading expert in photonic curing equipment. And photonic curing is basically heating a very thin layer with a pulse of light very quickly. Okay, and so that lets us do very unique thermal profiles. And today we've adopted that technology to do a soldering process. So normally we work with very thin layers of materials like nanometers or microns.
Right.
But we figured out that we could use a lot of the same equipment that's already been developed for many years now, and we can kind of change the recipe, and we can use it to reflow solder joints.
Really?
So for like surface mount components and BGA and things like that, it's actually really ideal. Our light source is a xenon flash lamp, and xenon is special because it allows us to use a very high energy density or power density. So using the machine, we can sustain over like 200 watts per square centimeter of light output or absorbed radiance on a sample. Which if you tried to do that with like LED or any other kind of light source, like you can't even get to 10% of this. So it allows us to do thermal like reflow profiles
Yes.
very quickly. So like these are our little trade show samples that we manufacture and give out. But the unique part to this is that the reflow process for this whole device only took about two and a half seconds. Okay.
Oh.
So the conventional process is you put this in a reflow oven,
Yeah.
and then like 2 or 3 minutes later it comes out the backside. And so we're doing the soldering process with a beam of light, and it's a large area. So unlike laser soldering, we're not just doing one little point at a time. We're doing a large area, all in like 2 or 3 seconds on these.
So how does this is the machine? I'm guessing.
Yes.
Where does this go? How does this work?
So the beam of light. One second. There's a safety delay here. So we have a sample tray, and this is actually our R&D machine. So if somebody comes to us and they says, "Hey, we want to develop this process for like a reflow oven," we've got a small area or a larger area to work with here, and based on the recipe we develop on here, we can scale up to an actual like throughput like reflow oven. Okay. So the beam size in this one is 75 by 150 millimeter. So we're doing this entire area in like 2 to 3 seconds on these.
Yeah.
If there's more mass to the circuit board or to the flex PCB, then it can take longer. But still, we're operating in like the single-digit number of seconds to do a reflow process. It's traditionally 90 seconds or 120 seconds or something like that.
So the idea is to like mass produce. I don't know if that's the right word, mass produce, but to be able to move it over to this system. This is the R&D.
Right.
This is the learning training one. You decide it, and then you move it over there, and you can do more and more.
Right. So these are more affordable. They're more compact. It kind of goes into a lab environment much better than maybe one of these.
I got it. Okay.
Okay. And then also we have some other environmental controls and things on here that we can add. If you don't need that in the production environment, then Then anyway, it's easier to sort of customize things here and do a sort of really wide array of processing conditions. And then once you know exactly what that is, you order the production tool.
Okay, so one more time, what is the name of this particular product we have here?
This is the PulseForge Invent. And the PulseForge Invent covers a really wide configuration of machines. And then once we kind of figure out what configuration is ideal, then you scale up to the production tool. But the production tool, it's really a lot of the same electronics.
Yeah.
It's the same lamp, it's the same reflectors. It's just built in a larger way with a large throughput oven underneath it. So you're not going back to the beginning. The beam is the same, the electronics, the software is the same. So things should scale really nicely. Now, let me point out one really unique feature to this.
All right.
A lot of our one of the most interesting things about this is the thermal profile that you think of for reflow is for the temperature going all the way through the stack. Okay, so when you think of a reflow profile, the entire device is at the temperature of whatever you're your point in time is on the ramp, right?
Yeah.
So because we're heating things so fast here, we can actually have a thermal gradient from the top to the bottom.
Yeah.
Right?
Yeah.
And with having a thermal gradient, maybe you need to solder a thermally sensitive component. So you've got a component that can only get to 80 or 100 C, but you need to do a 230 C reflow profile on there. Because of the speed that we're operating at, we can actually keep certain parts of the component cool while the backside of it is doing this thermal process.
Got it. Very interesting stuff here. Thank you so much for taking the time out of your day to show us.
You're welcome.
Appreciate it.
Thanks for coming by, sis.
And good luck with everything.
You too.